Okay, so we are going to discuss stoichiometry. We're going to do this in 3 different steps. Okay, so this is the first step. So these are some problem conventions that you should use whenever you do a stoichiometry problem. So the first thing is to list the known and unknown quantities, including the units. You can abbreviate known and unknown with K and U if you'd like. You must use train tracks at all times and cross out the units. You must use all your units at all times, and the units should have a chemical compound associated with it. And you should draw a circle or box around your final answer, and then, of course, include the units with your final answer. All right, so stoichiometry just refers to the relationship among quantities of reactants and products in your chemical reaction. So we're going to use the chemical reaction much as a recipe to tell us things about how much of some material we need to produce a certain thing, okay, a certain compound. So there's 3 different steps. The first step is always to find the number of moles from the known quantity, all right? So that's step number 1. Step number 2 is to use the balanced chemical equation to determine the number of moles used and produced from the unknown from the known. So this is where we use our mole ratio right here. And then lastly, we just convert that then back into whatever quantity you want to know, whether it's molecules, grams, or liters. Every once in a while, you might just need to know the moles, and so then you wouldn't have to do step 3. Okay, so let's talk about step 1. Finding the number of moles from the known quantity. All right, we're going to use 3 different things to do that. All right, there's 3 conversions we can use, and this depends on the units that your known quantity is in. So the first thing we can use is this right here, Avogadro's number, which tells us that 1 mole equals 6.02 times 10 to the 23rd molecules. The second thing we can use is the molecular mass. This is where we use the periodic table to tell us how much mass there is in 1 mole of substance. So for example, there is 18.02 grams in 1 mole of water. All right, so we might need to use that to transfer from grams to moles. And then lastly, if it's a gas at standard temperature and pressure, which is defined as 25 degrees Celsius and 1 atmosphere, all right, we can use this relationship that 1 mole is equal to 22.4 liters of gas. But that's only for a gas. We cannot use that for a liquid or a solid. All right, let's do some examples. So the first one here, we're going to use the Haber-Bosch process where we take nitrogen plus hydrogen to give us ammonia. And I have already balanced this for you. So the way we set this up is we write our known quantity here is given to us in our problem. So we ask how many grams of ammonia is produced from 9.8 times 10 to the 23rd molecules of nitrogen. So our known quantity is our 9.8 times 10 to the 23rd molecules, it's a little messy, of nitrogen. All right, our unknown is what we want to know, and what we want to know are the grams of ammonia. All right, the way we set this up is we use train tracks. We're always going to put our known quantity on the top left, so we just put that in here, 9.8 times 10 to the 23rd molecules of nitrogen. All right, now to use the train tracks, remember we want the units catty corner from each other, top and bottom, to cancel. So we're going to put molecules of N2 down at the bottom, and we are converting to moles of N2. All right, now the relationship we have here that would work is that 1 mole of nitrogen equals 6.02 times 10 to the 23rd molecules of N2. All right, and that would be step 1. So let's go ahead and calculate that. 9.8, I'm putting it in my calculator. And I recommend you do this also. Remember that for most TI, I think you have to put your scientific notation in parentheses to divide. All right, and I end up getting, I'm going to round to 2, 1.6, and our units now are going to be moles of N2. All right, and that's step 1. All right, let's go ahead and look at the case for when you're given a different known quantity. So here we have another case. So the same equation, but now we know, our known is that we have 6.5 grams of hydrogen. Our unknown is the same. How many grams of NH3 can we produce? Now we're just going to do step 1 here. So using train tracks, we're going to put our known quantity up here. All right, we're going to need some relationship between the grams of H2 and the moles of H2. Right? To find this, we need to look at the periodic table. Now we know that for hydrogen, the AMU, all right, is equal to 1.01 grams per mole. So that means for H2, it's going to be 2.02 since there's two hydrogen. And many gases are that way. It's what's called diatomic. There's two elements that get together, H2, O2, N2. It will be common. And that's in 1 mole. All right, if we calculate this, you just take 6.5 divided by 2.02. We get 3.2. Now, these cancel out. Moles of hydrogen. That would be our final answer for step 1. All right, and there is one more case. So finding the moles from liters. All right, so say that we know, our known is that we have 65 liters of N2. All right, our unknown then will be still how many grams of ammonia we can produce. All right, so set up our train tracks, 65 liters of N2. We're going to want liters of N2 on the bottom here, moles of N2 on the top. Our liters will cancel. So here we can use our relationship that we know that there's 22.4 liters in 1 mole of N2. So we say 65 divided by 22.4, and we end up getting 2.9 moles of N2. All right. So that is step 1 for all 3 cases for this equation. Here's another example that it has more compounds in the chemical equation, but we just have to worry about the known and unknown. You don't need to pay attention to anything else. So this is lithium nitride. It says lithium nitride reacts with water to form ammonia and aqueous lithium hydroxide. So we want to know what mass of water is needed to react with 32.9 grams of lithium nitride. All right, so our known here is our 32.9. Oh, and go ahead and pause this, you guys. Pause this and work it and see if you get the correct answer, and then come back and, yeah, just to make sure you can do it. All right, grams of lithium nitride. All right, and our unknown here are grams of water. Now let's just do step 1, all right? So we have 32.9 grams of lithium nitride, right? Now we're gonna need to figure out how many grams of lithium nitride, and I recommend writing it all out, are in 1 mole. Now we have to go to our periodic table, all right? Lithium has an AMU of 6.94. So we multiply that by 3, then we add nitrogen, which is 14.01, and we end up getting our 34.83 grams per a mole. So we take 32.9 divided by 34.83, and we get 0.94 moles of lithium nitride. And that would be our final answer for step 1 only, all right? So that concludes step 1. The next video, we will go one more step and talk about step 2. All right, now we are on to the final step. So this is the final step, step 3, for our general stoichiometry problems, all right? And that is just converting the moles back to the unknown quantity, okay? So whatever units we want to know. So let's go ahead and do that. All right, so the first one, so we know that we have 9.8 times 10 to the 23rd molecules of N2. We want to know how many grams of NH3 is produced. Okay, so now we're going to have 3 steps. The first step, converting to the moles, 9.8 times 10 to the 23rd molecules of N2. We know that there are 6.02 times 10 to the 23rd molecules in 1 mole. All right, mole ratio time, we use moles of N2 to moles of NH3. All right, and from the equation, we know there's 2 to 1 here. All right, now we're asked for grams. So for 1 mole of NH3, now we have to determine how many grams we have. We'll have to look that up on the periodic table. So nitrogen is 14.01 plus 3.03. That ends up being 17.04. All right, so calculating that times 2 divided by. All right, and if I did this correctly, we end up getting 55 grams of, and that's NH3, of NH3 for that many molecules. All right, and that gives us, that's how much ammonia we can produce with that many molecules of nitrogen. So that's all 3 steps. All right, let's go ahead and do the 2 other cases. So this is kind of just almost doing the first step in reverse, but just now with the unknown instead of the known. Okay, so here we go. Here's our known quantity, is that we have 6.5 grams of H2. Our unknown now, we're going to want to know the molecules of NH3. Okay, so let's go ahead and set this up. Our given goes up here, 6.5 grams of H2. We know that there's 2.02 grams of H2 per 1 mole from the periodic table of H2. And I recommend writing out mole H2 each time, all right, just to make sure that you put everything in the correct spot. For a mole of H2, we need to know our mole ratio now. So here from our equation, we know that for 2 moles of NH3, we use 3 moles of H2. All right, and then lastly, we're trying to go to molecules. So we're going to want to know moles to molecules here. We know that for 1 mole of NH3, we have 6.02 times 10 to the 23rd. All right, so making sure our units all cancel out, which they do. Wonderful. Now we'll just calculate 6.5 divided by 2.02 times 2 divided by 3 times 6.02 times 10 to the 23rd. And we get that there's 1.3 times 10 to the 24th molecules of NH3 produced. And that would be our final answer. All right, one more case again. So our known, right, is our 65 liters of N2. Our unknown, right, how many liters of ammonia, all right? So now we're going from liters to liters. So we start with our 65 liters of N2. We know that there's 22.4 liters of N2 per 1 mole of N2. Now we use our mole ratio going from N2 to ammonia, and that's going to be our 2 to 1 ratio for this one. Then lastly, we're wanting to go back to liters. Now something interesting I think is going to happen here. All right, so we put it in, and you can see that since our conversion our 22.4 liters in 1 mole does not depend on what type of gas it is, these actually cancel out. So interesting, isn't it? So anyways, our final answer is just going to be 65 times 2. It's going to give us 130 liters of ammonia. All right, and everything cancels out. That would be our final answer. All right, let's do one more problem. So this is our lithium nitride problem. Go ahead and set this up on your own and make sure you can solve it And then check and make sure you got it correct. So our known for this one is our 32.9 grams of lithium nitride. Our unknown, all right, is the grams of water. Okay, so go ahead and set that up. So 32.9 grams of lithium nitride. I'm going to put that on the bottom to cancel per 1 mole. And from the periodic table, it is 34.83. All right. Now our mole ratio, 1 mole of lithium nitride gives us 3 moles of water. Right, and then lastly, we know that 1 mole of water is 18.02 grams. All right, so canceling out our units. Now we multiply everything on the top. Times 3. And divide by the bottom. Oh, that's 1. And what I end up getting is that this is 51.1 grams of water. All right. So when we go grams to grams, you cannot cancel out like we did with the liters, just this last one. But that is step 3. Okay. So stoichiometry, we are now going to start with step 2. So the last video, we talked about how to determine the number of moles from the known quantity. Now we are at step 2, where we're going to go from our known to our unknown quantity. And to do that, we are going to use our mole ratio, okay? So let's go ahead and do some examples. These are the same examples from the first video. Now we're just going to be progressing one more step. All right, so we are going to ask how much ammonia, and we're going to assume that's grams, is produced from 9.8 times 10 to the 23rd molecules of N2. All right, so our known quantity, right, 9.8 times 10 to the 23rd molecules of N2. Our unknown, we're going to say, is grams, and we will not get to that today, but we're getting there. All right, so now we're going to need to use our mole ratio. Now we're going to want to go from N2 to NH3. Now to do that, we're going to use the mole ratio. So we're going to want to know how many moles of N2 there are for moles of NH3. Remember, what you want to know, the unknown should be on the top. To do that, we have to look at our chemical equation, and our equation gives us a relationship. So it tells us how many moles of N2 we need to make how many moles of NH3. So we just take the coefficients from the chemical equation and put them in front of our quantities here. So we know that 2 moles of NH3 require 1 mole of NH2. We're going to go ahead and set up our train tracks. We're going to have another step here. We're going to start with step 1, 9.8 times 10 to the 23rd molecules of N2, right? We're going to want molecules of N2 on the bottom here. We're going to go to moles. That's always the first step, is to find the moles. All right, and we know that 1 mole of N2 will give us 6.02 times 10 to the 23rd molecules. All right, the next step, we want moles of N2 on the bottom. Now we're finding a relationship between our known and our unknown. So we want that on the top, so we can use our mole ratio here. Okay, so if we calculate that, so we multiply everything on the top, divide by the bottom, we end up getting 3.3 moles of NH3 from that many molecules of NH2. And that is the end of step 2. All right, let's do the 2 other scenarios. All right, so it's going to be similar. So our known here is our 6.5 grams of hydrogen. Our unknown is still the same, grams of ammonia. All right, let's set up our train tracks. So we know we have 6.5 grams of hydrogen. All right, we have to use the AMU from our periodic table. We know that there's 2.02 grams of H2 in 1 mole. Right, now our mole ratio. So we're starting with moles of H2. We're wanting to find moles of ammonia. All right, now we look at our chemical equation. So for 2 moles of ammonia, right up here, right, we need, you can see 3 moles of NH2 here. All right, so what we do, once again, we just multiply everything on the top. Now we're going to be dividing by 2 quantities on the bottom. So dividing by 2.02 and 3. And you can do that whichever way you want. It does not matter. Times 2. So I'm taking 6.5 times 2 divided by 2.02 and divided by 3. And we get 2.1. 2.1. All right, now crossing out all our units here, we can see that we're left with moles of NH3 for step 2. All right, and last case here. This is when our known is in liters. So 65 liters of N2. Our unknown here is grams of NH3. Okay, we're going to set it up. So we're starting with 65 liters of N2. We need to convert to moles first from liters. So we use our 22.4. All right, then we're going to want to know moles of N2, 2 moles of NH3. We know that's 1 to 2. All right, go ahead, take 65 divided by 22.4 times 2. We end up getting 5.8 moles of NH3 for this one. Canceling out, making sure everything's correct. That's the final answer. All right. Now, one more. Okay, so go ahead and do this on your own. We know that our known here is 32.9 grams of lithium. I should have kept that nitrate. Our unknown, right, is grams of water. All right, so let's go ahead and set this up on your own and make sure you can do it correctly, and then I will show you. Okay, so putting the known up here, 32.9 grams of lithium nitrate. And finding, I should have 6.94 times 3 plus, right, remember that's 34.83 grams from the periodic table per 1 mole. All right, now we're converting from moles of lithium nitride to moles of water. Now from our equation, we can see that we need 3 moles of water for 1 mole of lithium nitride. All right, I'll do this calculation. And we end up getting, it's 2.8 moles of water. All right, canceling, making sure these all cancel out, and put a box around it, and we are done. All right, that's the end of step 2.